Hey everybody, welcome to Module 5. Today we are going to be learning about epidemiology, one of my favorite subjects. So what I want you to think about first is what would be the most definitive way to figure out how a disease spreads. So what would be a method you could use to figure out how a disease spreads that would leave the fewest questions or things to wonder or variables? So there's a lot of ideas you could have come up with. What I thought of is to have a person who's infected by the disease try to spread it to others and see what works. I'm thinking an experiment with independent variables, dependent variables, controls, a very controlled environment where if I'm the experimenter, I am like purposefully exposing people to the virus and seeing what encourages the spread and what doesn't. Hopefully you're asking yourself, like, what the heck? That is not okay. That is very wrong to purposefully expose people to viruses, because it is. So scientists can't conduct a study like the one I just described, mostly because of ethics or morals. So we cannot, in the name of science, in the name of medicine, purposely harm people or even carelessly harm people. If there's any indication that a person could be harmed through a study, we wouldn't do it, okay? So what we can do to figure out how diseases spread and what makes them spread more easily is look for correlations. And you might be thinking, correlations are not as strong as doing an experiment and finding a causation. That's true, but the correlations we're talking about here are very, very strong correlations based on a lot of data. This is all done through a study called epidemiology. And the direct definition of epidemiology is, as you can read, the study of the distribution and determinants of health-related states in specified populations. This is not the definition you are adding to your notes. As you can tell, this definition is very convoluted and complicated. So let's break it down a little bit. What does epidemiology actually mean? So first, when we say distribution, we mean the frequency or the amount or the patterns, okay? And then when we say determinants, we mean like causes and risk factors. Health-related states are things like diseases, and like COVID-19 right now, environmental impacts, things like lead poisoning or radiation. And it can even include injuries, like if we're seeing common injuries among a group of people. And then specified populations are like a neighborhood, a state, or a country. So if we simplify it, epidemiology is the study of how and why health issues impact specific groups of people. We're looking at strong correlations when we're looking at epidemiology, just like you looked at in the Solve the Outbreak game that you played before you started watching this video, right? You didn't know for sure exactly what clue to go with, but you could probably figure it out based on the process of elimination, some strong correlations that you were seeing among different variables. And then epidemiologists are the people that do this work. So there's a whole field of study and a whole career path where people are just focused on how and why health issues are impacting specific groups of people. So let's look at one example of epidemiology in action. So this is a really old example. In fact, it's one of the first examples of epidemiology being used. So this is the cholera outbreak of 1854, when this guy, Jon Snow, not the Jon Snow from Game of Thrones, unfortunately, but this Jon Snow was interested in why people in England were getting cholera. And people believed at the time that cholera was due to pollution. So this is a disease, right? And they believed that it was due to pollution in the air. Jon Snow created this dot map that you can see here of every person infected. So he marked where they all lived, all right? And he found by using this map that they were all using the same water pump, all right? He kind of figured that if it was due to pollution, then why isn't everyone in the city sick? right? A lot of people are sick, but not everyone is, and everyone's breathing the same air. And he found that one common thing among all of the people who were sick were was their water pump that they were using. And eventually it was discovered that cholera was due to sewage in those water pumps. So fecal matter in the water pumps was spreading that bacteria, and then people were getting sick and they were getting cholera from it. Right? So he wasn't purposefully exposing people to the disease, but he was tracing and using the data and information that he had to figure out where the disease was coming from and how it was spreading. Another example of epidemiology is smoking, right? You probably all have been told so many times that smoking cigarettes is bad for you. This is like relatively common knowledge right now, but it's not always been viewed as harmful. In fact, people were pretty unknowing of the impacts of cigarette smoke for a very long time, for many, many years. And then, as you can see down here, it started to be seen that more and more people were developing lung cancer. And so when they looked at commonalities among the people who were developing lung cancer, one was age, clearly, and another really strong indicator was smoking cigarettes, right? We can't make people smoke cigarettes and see what happens, right? But we can see that with more years of smoking, right, and higher frequency of smoking cigarettes, people are increasing their risk of lung cancer, right? There's not a causation here. We haven't done an experiment that definitively shows that smoking causes lung cancer. But there is an extremely strong correlation that we are very, very sure, right? We're pretty sure that smoking and lung cancer are strongly connected. And so, like, we deem that risk pretty credible. So when we think about epidemiology right now with COVID-19, like, what is happening? How is epidemiology being used? One really interesting thing is people are acting as disease detectives, epidemiologists, kind of creating, I mean, this is a very simplified model, but creating models like this to trace who has been contacted and how the virus has spread. You're going to be reading about some of these disease detectives a little later in the module today. But yeah, they're doing this incredible work to contact people and let them know they've been exposed, and researching people who've tested positive for the disease and understanding everywhere they've been and everyone they've been in contact with in recent weeks. Really, really interesting stuff, and a lot of hard work is going into it. Oh, and sorry this cut off, but it's also being used to understand the people and places being impacted the most by this disease. So you probably already figured out this is a map of Denver. The darker colors indicate higher rates of the COVID-19 disease. Lighter colors represent fewer numbers, lower frequency. And what we're seeing is that neighborhoods with more people of color and more people with low incomes are seeing higher rates of the disease. So we're seeing that, like, income is actually a strong predictor of how severe this disease can get, and unfortunately race as well. And epidemiologists are doing the research to find this data so that we can better understand what's actually going on. Epidemiologists are also making predictions about what will happen next, like immediately next and in the long term. And one of the strongest examples, as you all have probably heard about, is flattening the curve. So the whole reason we're doing all these things to prevent COVID-19 from spreading, well, part of it is flattening the curve, right? So there was a huge concern when the virus first started impacting the states that there was going to be this huge spike in instances and cases, and that hospitals were not going to be able to take care of all of those patients, and they were going to overflow the system. But by flattening the curve, we're kind of spreading out the disease, right? Lowering those overall numbers and allowing hospitals to do better work with the people that are in the hospitals, right? All of these are were simply predictions, right? These things hadn't happened yet, but they were predictions made by epidemiologists who knew the system and were able to use past data to make predictions about the future. As you're hearing on the news about when like stay-at-home orders should be lifted, how the next year or so of our lives are going to look, they're using epidemiological research. All right. Epidemiological research is also being used to give the recommendations to stop the spread, right? Just like you all developed last week in your visuals that you created, which were all so excellent. They're seeing like using the data from, the disease detectives and how is the disease spreading to better understand how to prevent the disease. All right. So a lot of this comes from like our knowledge of viruses, but we also know that viruses are different, right? Some viruses spread through droplets, some only spread through transmission of bodily fluids. We know more about COVID-19 because of that epidemiological research. All right, so what are you going to do next? You are going to interact with some examples of how epidemiology is in action and it's being used right now. So right at this moment where we are trying to slow this pandemic down and get lives back to as normal as possible, right? Epidemiologists are on the front lines of that research. Then you're going to build your knowledge so that you are prepared to act as a COVID-19 epidemiologist. You will get more information on that later as you go, but make sure you're really paying attention to your activities that you do next so that you are ready to communicate some epidemiological research of your own. Go ahead and continue on to your next activity in the module, and I will see you all later. Bye.